Hey guys, welcome back. This is part 2 of the lesson on Introduction to Polynomials. We're going over this quiz that we had. So far we've already talked about how to know whether or not something is a polynomial. That was in part 1. And we talked about some basic polynomial terminology: degree, leading coefficient, standard form, and naming a polynomial like so. But now we're going to move on in this video and talk about Pascal's triangle and using it to expand a binomial. Alright, so in other words, we're going to write this out without parentheses, but we are not going to go x minus 6 times x minus 6 times x minus 6 times x minus 6. Alright? That would take a long time to do, so Pascal's triangle definitely helps us get it done quickly. Alright, so what is this Pascal's triangle of which you speak? Alright, you should be able to build Pascal's triangle at will. It always starts off with, a small triangle of ones like that. And then what you do to form the rest of the rows of Pascal's triangle, you start adding. So take two numbers, add them up, and put the sum in between. So 1 plus 1 is 2. At the ends of the row are always ones, so you can put the ones in. So if you continue that pattern, 1 plus 2 is 3. So, and same thing here, so that's 3 and 3. On the ends will be ones. Alright, 1 plus 3 is 4. These two make 6, and these two we're back to 4 again. Alright, we put the ones on the ends. Okay, 1 plus 4, that's 5. These two make 10. There's another 10. There's another 5. And the ones go on the ends. Okay, I'm going to go out one more row if I can. Okay, so these will make 6, and then 15, and 20, and 15, and 6, and put these ones on the ends. Okay, you can't quite see it. There's a 1 off camera there. Just off camera, I can't quite get to it. But trust me, it's there. Alright, now, what about it? Well, it turns out that each row of Pascal's triangle are the coefficients of a binomial if you expanded it. So, for example, this first row is the coefficient that you would get if you took a binomial and you raise it to the 0 power. Of course, anything to the 0 power is 1, so that makes total sense. The second row, these would be the coefficients you would get if you took any binomial and raised it to the second power. I'm sorry, I skipped a degree. Raised it to the first power. And that makes sense because if I did x plus y to the first power, that wouldn't really change anything. So it would just be x plus y, 1 and 1. And it just continues on from there, 0, 1, and it just keeps going up. So this would be the coefficients of a binomial, a second degree binomial. This would be the third degree coefficients. Okay, these would be the coefficients for fourth degree. Messed up a little bit there. Sometimes it's hard for me to talk and write at the same time. Okay, and these would be our coefficients for the sixth degree. 0, 1, 2, 3, 4, 5, 6. And we could go on from there higher and higher, the 100th degree, whatever you want. But this will surely be enough for our purposes today. So, I wonder what it looks like in black and white. That is really weird. Maybe I'll keep it like this for right now. Okay, so if I want to do x minus 6 to the fourth power, alright, so the degree is 4, so that means we are dealing with these coefficients, 1, 4, 6, 4, 1. So if I were you, I'd start out by just writing down those coefficients. Okay, those coefficients are 1, 4, 6, 4, 1. And you should space them out the way I did. Okay, next we're going to start with the x. The x is on the left, so we're going to start with the x values on the left. So put it right next to that 1. Since the degree is 4, we start with x to the fourth power. And then it's going to decrease from there. So it'll be x to the third power, x to the second power, and just plain x. And this one would be x to the 0 power, so we won't put any. By the way, these always start off positive, so I'm going to put plus. Okay, next we move over and let's look at that negative 6. Let's see. I'll do green. So looking at the negative 6, it's on the right, so we're going to start off with our negative 6 on the right. If I were you, I'd put it in parentheses. And again, the degree is 4, so we're going to start off with negative 6 to the fourth power. And now we're going to go to the left, decreasing the power every time. So this is going to be negative 6 to the third power. And here we'll have negative 6 squared. And then this will just be negative 6. And then this last term doesn't get any negative 6's. Alright, so all we really need to do is simplify this. Now if I were you, I would start by doing all the powers. Okay, so specifically the negative 6 squared, third power, fourth power. Let's evaluate all of those powers. Thinking order of operations. Exponents come before multiplication, so that's why that should be our first move. So I'm just going to sort of color coordinate everything. So first of all, the coefficients, I'm going to leave them just where they are. Okay, so there are all my coefficients. Alright, my variables are not changing. Okay, the only thing that might change are these numbers raised to a power. So for right now, I've got negative 6 has no power, so that's just going to stay negative 6. Now, negative 6 squared is a positive 36, so I'm going to make that change. Alright, of course, if you raise a negative number to an even power, it turns positive. Negative 6 to the third power is 216. Okay, you might not have known that one in your head like I did. So you would need a calculator if that was the case. And if you want to put the whole thing in your calculator, including the negative sign, please just make sure you use parentheses. So I go negative 6 to the third power. And did I put positive 216? Whoa, okay, that was a very foolish mistake on my part. I just said that if you take a negative number and raise it to an even power, that's going to be positive. But if you take a negative number and raise it to an odd power, of course that's going to stay negative. So that was an embarrassing, careless mistake on my part. Okay, so negative 216. Alright, and then a negative 6 to the fourth power, this is going to be a positive number once again. So let's go ahead and do our negative 6 to the fourth power. Alright, so that's positive 1,296. Let me just point out to you the importance of using parentheses, because if I do negative 6 to the fourth power without the parentheses around the negative 6, it's going to tell me negative 1,296, which is not what we wanted. Alright, we want negative 6 times negative 6, not negative 6 times 6 times 6 times 6. So use parentheses if you're going to use a calculator. So 1,296. So in general, the signs, if you have a negative number as your second term, the signs should alternate: positive, negative, positive, negative, positive. So just watch out for those signs to alternate like that. Alright, so now we're ready to clean this up and get on to the final answer. Alright, so let's go ahead and do the multiplication and get rid of any unnecessary ones like this. So this is going to just be x to the 4th power. Alright, and here we have 4 times negative 6. That is negative 24. And we still have our x to the 3rd power. And then we'll have plus 6 times 36. That's going to be a 216. So I'll have 216 x squared. Okay, now 4 times negative 216. I'm going to use the calculator to help me out on that one. So 4 times negative 216. Of course, we know it's going to be negative 864. So we have negative 864x. And then, of course, we have our plus 1,296. Alright, and that's it. So this should be the answer for number 8. Alright, look at number 9. X plus 3 to the 5th power. So, glancing at our Pascal's triangle, see, this is the 5th power. This is going to be long. Alright, the 5th power, the coefficients are 1, 5, 10, 10, 5, 1. Okay, it's going to take a lot of space. Might have to write small. Okay, so the coefficients are 1, 5, 10, 10, 5, 1. Okay, and they always start off positive. Okay, so we will start with the x on the left. Okay, the x on the left, start with the 5th power, so that'll be x to the 5th power, x to the 4th power, x to the 3rd power, x squared, and x. Last one doesn't get any x's. Alright, now we'll switch over and look at the 3. Alright, the 3 is on the right, so we start off on the right with 3 to the 5th power, and then decreasing from there, 3 to the 4th power. Alright, 3 to the 3rd power, 3 squared, and just plain old 3. The last term doesn't get any 3's. So just like I did before, let's do all of these powers first. So I'm going to recopy everything else the way it is. So I've got 1, 5, 10, 10, 5, 1. Okay. Alright, I was just thinking there for a second. Then the variables, I've got x to the 5th power, x to the 4th power, x to the 3rd power, x squared, and x. So now I'm just going to go ahead and do these powers of 3. 3 is still 3. 3 squared is 9. 3 to the 3rd power is 27. 3 to the 4th power is 81. And 3 to the 5th power, Okay, I'm just forgetting what that is right at the top of my head. 3 to the 5th power is 243. Okay, so now we can go ahead and do our multiplication and get our final answer. So this is going to be just x to the 5th power. 3 times 5 is 15, so 15 x to the 4th power. 10 times 9 is 90, so plus 90 x to the 3rd power. 10 times 27 is 270, so plus 270 x squared. 5 times 81, need a little help on that one. Okay, it's 405. And then 243. So this should be the expanded form for x plus 3 to the 5th power. Okay, and number 10. Okay, 3x plus 4 to the 3rd power. So if we're talking about the 3rd power, we're talking about the coefficients 1, 3, 3, 1 for the 3rd power. Okay, so 1, 3, 3, 1. So let's spread that out. We've got 1, 3, 3, 1. Okay, and they all start off positive. So on the left we have 3x, so let's start with that. Now I recommend putting this in parentheses since there's more than one factor here. So I'm going to start off with my 3x, but it's 3x to the 3rd power based on the degree. Decreasing from there, I've got 3x to the 2nd power, and then I've got just plain old 3x, and the last term doesn't get any 3x's. Now I'm going to switch over and look at the 4. Alright, 4 is on the right, so I'm going to start off putting a 4 on the right. 4 to the 3rd power, that's the degree. And then decreasing as we go to the left, so we'll have 4 squared, and then just a plain old 4, and the last term doesn't get any 4's, alright, because it's 4 to the 0 power. Alrighty then. So, our next move is to do the exponents. So this time we need to worry about the variable part as well, because we have to do, for example, 3x to the 3rd power. So let's get rid of all of these exponents. But first, I'm just going to recopy my coefficients. So I have 1, and 3, and 3, and 1. So now I'm going to do all the variable part. Now be really careful on this. 3x to the 3rd power is not just 3x to the 3rd power. Okay, that's why I put this in parentheses to remind us. We have to do 3 to the 3rd power and x to the 3rd power. We got to cube all of it. 3 to the 3rd power is 27, so this should be 27x to the 3rd power. Okay, 3 squared is 9, so this will be 9x squared. Okay, and then we just have 3x. Okay, so now we've dealt with squaring the variable part. Now let's go back and deal with squaring the number part, the green. Okay, well we just have 4 to the 1 power here, so we'll just keep that. Of course, 4 squared is 16. 4 to the 3rd power is 64. Okay, so now we can go ahead and do the multiplication part of this project. Of course, 1 times anything is just itself, so we have our 27x to the 3rd power. Now here we have 3 times 9 times 4, So 3 times 9 times 4. Okay, that's 108. So we can go ahead and do plus 108 x squared. Here we have 3 times 3 times 16. Okay, that's 144. So we'll have plus 144, and this one is just the x term. And then last we just have our 64, so plus 64. Okay, so this would be 3x plus 4 to the third power if we expanded it like this. Alright, so we're switching gears with number 11 as we're doing some function operations. So let's go ahead and stop this video here, and I'll pick up with function operations on the next video. So I will see you on the next video.